Hello everyone. Today we're going to continue with derivatives of log function. Okay. Just quick recap about ln. Okay. So ln x is also equal to log x. Okay, for example, if ln x equal to 4, so log x is also 4, where x is e to the power of 4. E tu, okay, ni bawa naik ke atas, okay. Okay. And also ln e is equal to 1. Okay, so now for better understanding about these properties, we shall look at the example. So for example 14, okay, we start with A. Okay, so A is find the derivative for y equal to ln 2x to the power of 8. Okay, the formula is ddx of ln x is equal to 1 over x. So for this one here, dy dx for ln 2x to the power of 8 is 1 over whatever is in the bracket here, 1 over 2x to the power of x, and don't forget to do the ddx of whatever in the bracket. Okay, the ddx of 2x to the power of 8. So 1 over 2x to the power of x, ddx of this one should be 16x to the power of 7. Okay, so simplify this. You will get this one here is 8, and x to the power of 7 divided by x to the power of 8, you will get this one should be 1. So the final answer is 8 over x. Okay, so remember to solve the derivative of logarithm function, the formula is the ddx of ln x equal to 1 over x. Okay, so for in this example, we have ln 2x to the power of 8. Okay, first you whatever in the bracket here, you put 1 over 2x to the power of 8. Okay, and multiply with the derivation of whatever in the bracket. Okay, there is 2 steps here. Okay, first whatever in the bracket, you put like this, okay, and then divide with multiply with whatever in that bracket. Okay, I hope you can see this. Okay, so I hope with more example you will have a clearer view on how to solve equation that involve log functions. Okay, so for now, for B is y equal to x squared plus 1 times with ln x. So looking at this equation, you can see how many functions? There is 2 functions, which is x squared plus 1 and ln x. So when you have 2 functions close together, what formula should you use? Class? Okay, I know no one will answer this, but okay, you should use dy dx uv prime plus vu prime. Okay, so u here is x square plus 1. U prime should be what? 2x. And ln v is ln x. And v prime should be 1 over x. Okay? So, for this one here, dy dx of uv prime, x square plus 1 over x plus vu prime, 2x ln x. And this is the final answer. Okay? Okay, now let's look at C. C is, oh sorry. Okay, my mistake here. In case you did not see it. Okay. Okay, so now we will do C. So C is y ln x plus 1. Oh sorry, x plus 1 over x minus 1. Okay, looking at this equation, first, remember the first rule to do dy dx for ln is you put whatever in the bracket here to be 1 over x plus 1 over x minus 1 and multiply with the ddx of whatever in the bracket. So for this equation, this question, it is x plus 1 over x minus 1. So this part here is sort of settled already. So we have to do the ddx for this part here. Looking at this kind of equation, what comes into your mind? How can we solve this? Okay, we can. So whenever you come across this pecahan or fraction or numerator denominator kind of question, you should use the quotient rule. Okay, so for the quotient rule, the formula is vu prime minus uv prime over v square. So u here is x plus 1. U prime should be what? 1. And v is x minus 1. V should be 1 also. So put this part here into here. Okay. So vu prime is x. Okay, where should I do this? Okay, I should do okay, x minus 1 times with vu prime times 1 minus u x plus 1 times 1 also over v square, x minus 1 square. Okay, we do it one by one. X minus 1 minus x minus 1. So x can be cancelled together. Final answer you will get minus 2 over x minus 1 square. Okay, not final answer. Final answer for this part here. Okay, for this part here. Okay. Okay, I'm going to erase some part of equation here so you can properly see. Jeez, I forgot to turn on the record button. So yeah, okay. So if you remember, we have solved the ddx of x plus 1 and x minus 1 here, and we get minus 2 over x minus 1 square. Okay, and this x plus 1 over x minus 1 can be rearranged like this, right? X minus 1 on the top, x plus 1 on the bottom. Okay, times with minus 2 over x minus 1 square. So x minus 1 square can be crossed, and the final answer should be like this. Okay, so now we're moving on to the next question. Oh my gosh, guys, I've forgotten to turn on the record button again, and I've just been mumbling to myself, so I don't know which part here. Okay, again, this is so frustrating, really. Okay, so the question is ln cos square x. Ln cos square x can also be rewritten like this, cos x square, where everything is square, cos square, x square. But if you have cos x square, you cannot write it like this, okay? For this part, only x is square, cos not square. Okay, so now we have y equal to ln cos square x. Our mission here is to find the dy dx for this one here. Okay, so dy dx of ln cos x is, remember, 1 over whatever, for ln 1 over whatever in the bracket. So 1 over cos square x times with the ddx of whatever function in the bracket. Okay, so the ddx of cos x square. Okay, we write it like this, cos x in bracket square, to make us easier to solve the equation later on. So 1 over cos square x times with 2 bring to the front, so we'll get 2 cos x, rewrite back whatever function, times with the ddx of the function in the bracket. So the ddx of cos x, you will get minus sin x, and this can be simplified like this, 2 cos x over cos square x. You can cross cos x here because this one is cos square x. So the final answer is minus 2 sin x over cos x, where sin x over cos x is also equal to tan x. Okay. Okay, I hope you will get a fair view on how to solve derivative of log functions by now. So now moving on to question E. Okay, so I hope the record button is on now. Okay, so E is y ln e to the power of x ln x. Okay, I'm going to write it again, y ln e to the power of x ln x. Okay, remember the first rule to solve the derivatives of log function? Okay, 1 over whatever in the bracket. Okay, 1 over ex ln x times with the ddx of whatever in the function, whatever function in the bracket, ex ln x. Okay, this part settle, this part not settle yet. You have to derive this function ex ln x. Okay, so there is two functions close together here. Now remember, what formula should you use? We should use the uv prime plus vu prime, right? Okay, so u is e to the power of x, and u prime is also e to the power of x. Okay, so this is a formula we will come across soon, but for your sake here, you just have to remember the ddx of e to the power of x is also e to the power of x. Okay, so for v it is ln x, and v prime it should be 1 over x. Okay, and I'm gonna write it down again. 1 over ex ln x times with uv prime plus vu prime. Okay, uv prime e to the power of x over x plus ln x ex. Okay, so now we're going to solve it one by one. X plus ln x ex. This can also be rewritten like this, right? Ln x ex. Either way, you can cancel it together. You will get 1 here, and this part here can also be cancelled together. So it should be 1 over x ln x plus 1. Okay, easy peasy, right? Okay, so now we're moving on to question F. So for question F, it is quite lengthy, but I hope you can understand this. So 3x plus 1 to the power of 5 over 2 minus x to the power of 10. As you can see, there is no ln function here. Why should you use ln? Okay, because if you use ln, it will be much easier than to use the quotient rule. So now we have to apply ln on both sides, okay, of the equation. Okay, so this one should be ln y, okay, and this one should be ln okay. Okay, first we can rearrange it to be like this. Okay, remember class, ln a over b is also equal to ln a minus ln b. So this theory can be applied here. So it should be ln 3x plus 1 to the power of 5 minus ln 2 minus x to the power of 10. So manipulating the ln theory again, 5 can be brought to the front as well as 10 here. So it should be 5 ln 3x plus 1 minus 10 ln 2 minus x. Okay, so now we want to do the ddx of everything. Okay, so ddx of ln y equal to the ddx of 5 ln 3x plus 1 minus 10 ln 2 minus x. Okay, I'm going to erase something here, something on the front, on this part here. Okay, so now, sorry, okay, there's some problem with the ink. Okay, so we want to find the ddx for this part here, kan? ddx of ln y, you will get 1 over y dy dx, and the ddx of 5 ln for this part here. Okay, remember when you deriving ln 5 because it is outside the ln factor, so 5 over whatever in the function in the bracket. So whatever function in the bracket here is 3x plus 1 times with the ddx of whatever function in the bracket, which is 3x plus 1. Okay, minus 10 over 2 minus x times with whatever function in the bracket, which is 2 minus x. Okay. Okay, and the ddx of 3x plus 1, we will get what? Derive it with respect to x, you will get 3. And this one, you will get minus 1. Okay, so this should be 5 times 3 over 3x plus 1 minus 10 times with minus 1 over 2 minus x. Okay, so this equation can be rearranged like this. So y times with 15 over 3x plus 1 minus we get 10 over 2 minus x. Okay, however, don't forget, y here should be rewritten in its original form. What is its original form here? Okay, so y is 3x plus 1 to the power of 5 over 2 minus x to the power of 10 times with 15, 3x plus 1 plus 10, 2 minus x. And this should be the final answer. Okay, till next time guys. Okay, bye.